Hi friends, this is Arun. In this video, we'll have a look at binary search. This is a beautiful concept in terms of searching. Let's take the problem statement. I want to search an element in a given array, assuming the array is sorted. So it is having around 15 elements, 0 to 14. So totally 15 elements I have it. Okay. So typically what we do with brute forces, like we write a for loop and search one by one. Like we start from here until the end. We iterate, check, and finally so the best case is 0. If the element is the first element, let's assume I'm searching for 6, I'll get 1. Worst case is 97. So always we look for the worst case to estimate. Okay. So here the search time is like order of n. Okay. Is there any better way to do it? That is the answer is the binary search. Binary search, what we do is we assume like the array is sorted, and I mean it can be applied only in the sorted array. Okay, that is very clear. And in the sorted array, we split the array into two things. For example, like think like taking paper in a book for like I want, if you have a book of around 600 pages and you want to pick the 120th page, what you will do, you will just take the split the book into half, and you will check whether the page is above 150 or 200, and then you will split come back and split the half and then reach to the particular page, probably in 5 or 6 steps, right? Okay, so that's how human do it. Can we apply the same algorithm over here? So that is the idea of binary search. So I have a sorted array like a book where all the pages are in order, and I just split the array and say that like if I want to search for 33, I go to the center of the array, mid of the array, and say 53. So 53 is greater than 33. So I discard the complete upper part of the array, and I come back to the, I consider the array is only 0 to 6. Now I will go to the middle element and I'll check what is the middle element. It's 25. It is above or below? Yes, it's above. So I discard the second half of the things. Okay. Again, I have three elements. So now I will find the middle. So middle is 43. I'll check above or below. So I'll discard the above, and then I'll go back to 33, and then I'll get the exact thing. Okay. We got it around like 3 or 4 steps, right? Instead of 15 steps. So assume like if the array is of 15, we got it in like around 3 steps. Let's assume the array is of around 1,000. So in a linear search, your n is 1,000. So based on the input size, your search time increases. Here, whatever it is, like even if it is 1,000, you will discard the first 500 and go to the 250 and discard the 250 and go to the 125 and discard the 125 and come to 75 and discard. Like that, you go on. So here, the algorithmic complexity, time complexity is around like a log of n. Okay, it divides by half. Okay, so this is the beauty of binary search. Okay, and this is a simple algorithm. All we do is like we find the middle, we have the index, right? All we do is divide the index and check the value in that index, and then recursively call the same thing and again. And the better way of implementing a binary search is build a binary search tree. So we'll look into the look up the trees in the later things. But binary search tree is a tree where the left and right node is of certain properties. For example, if I have a root node 11, the right node has to be 33, which is higher than that, and left node has to be less than that, 6. Like that, it goes on. So that is the behavior of binary search tree. And if you construct a binary search tree, you will be able to construct, you will be able to do the binary search in an efficient way, and that is the best way to do it as well. Okay. Thank you, friends. Bye bye.